Hello everyone, we're here with a special video today that stems from a great question we got asked in our Discord community. So big shout out to this individual for asking a question about debouncing, what a debounce is, and how it could be used to solve a certain problem that they had on a lab in our course. Now, I told them that while the debounce could have solved the problem they had, it'd be akin to firing a missile at a nail that was sticking out of a piece of wood. Now, while that missile would obliterate everything and probably solve the problem, it'd be a lot easier if they learned how to pull a hammer out of their tool belt and hammer that nail back on in. So while they didn't use the debounce to answer the question, I did ask them if they were interested in a video about using a debounce or how to write one, and that's what inspired this video. So thanks again to our community member for asking this question and inspiring this video. Now, if you're interested in joining our community, you can check for a link in the description down below. For $25 a month, you get access to our front-end course, back-end course, and my standalone React course. I'm also in the working on a TypeScript and database standalone course, and as you can tell, you get additional help like us in our Discord community, and as well as videos, personalized video help like this if I have the time to make some content for you, and you ask a great question. Either way, like I said, just check in the description down below for a link to that. Otherwise, you have two choices here. Either you can go ahead and pause this video, look in the description down below for a Codepen so you can grab the HTML and style sheet text I have written so you could use it in your own code editor in your own mini project if you want to follow along. If you don't want to follow along, you just want to learn and internalize some concepts, maybe take some notes and just watch what I do, the final code of all of this will be available in a Codepen linked down below. So without further ado, we have a simple HTML with div label input, nothing to it. Nice easy IDs to select. I have my style sheet linked and my app.js sourced. So my style sheet code is nothing magnificent. It's just some simple Vaporwave style and some centering and some basic styling to make this beautiful looking web page right here, where I had this fake search bar we're going to be typing into here in just a moment to simulate what we're going to be doing with a debounce. My JavaScript file should be empty, unless I forgot to ditch it between recording sessions. So there we go. And before we dive on in, let's first understand what debouncing is. Right, so debouncing is a programming practice that ensures that time-consuming tasks do not fire so often. That's it. It's basically taking a function and delaying it for some set amount of time after some continuous or frequent action has occurred. This doesn't have to be completely user-generated, but it's easiest to understand from a user-generated standpoint. What I mean by that is, imagine we have a function that runs whenever the browser window resizes itself. If that function runs whenever that happens, it's running like crazy right now, and it'd be going all over the place and haywire, and if it's a very costly or non-performative or costly operation, it's running a lot right now. The debounce function would say, hey, that function that's going to run when the window resizes, wait for them to stop and then run that function. And that's all a debounce is. Besides window resizing, clearly search bar auto suggestions or text input validations are great use cases as well. Right? If I'm looking for the Hitchhiker's Guide to the Galaxy and I make some typos like I just did in this recording, then it should not be searching for every letter I type. It should only search after 3/4, half a second, quarter of a second have passed since I stopped typing. So rather than executing a search for each letter, we only execute a search after I've stopped typing for a brief moment, and that fires one instead of multiple searches. And we can see this in action in the following way. Let's go ahead and grab that text input, or that input node, so I can just go ahead and run get element by ID. I believe I called it search box. Let's double check so I don't make a complete fool of myself. ID search dash box. Perfect. We now have that input node. I can add an event listener to it that's going to have this input change function that says, hey, whenever an input happens on this node, input node, let's go ahead and run this function. Let's grab, nope, wrong one. Let's go ahead and grab the event object that should be generated by this function. That should be generated by this event listener and given to this function as a parameter. We're going to go ahead and console log search for and then space and then concatenate our eTarget value, which represents what a user is typing into that input, which is the event target. So with that little simple console log, let's go ahead and take a look at what happens here. The space hitch. And like I had said, this is overkill if this was a very performance heavy searching function or something or like that, right? Looking for T, then TH, then THE, then THE space, then THE space H, and et cetera, is complete overkill. And I would argue that all of these shouldn't be here and just the bottom one should be here, and that's it. So what we're going to learn is how this debounce function can be coded onto this so we can have all this ignored until we pause typing, and then it executes once, therefore highly optimizing our very unoptimized code as we're looking at it. But before I dive into the actual code of a debounce handler, which is actually not all that difficult, we do need to talk a little bit about a keyword in JavaScript that does make it a bit more difficult, which is the keyword this and what it means. I, as a teacher, hate having to talk. I like teaching. What's difficult about teaching this is not using the word this in its own definition constantly. And I feel like I lose my mind because I say the word this so many times while talking about it that I just lose track of what's happening. But the keyword this, it is context in JavaScript, and it differentiates how it works in traditional function syntax and arrow syntax. So the value of this, the context of this, in JavaScript is determined by how a function is called. If I first and foremost talk about this and we console log the keyword this outside of anything, what do we get? We get what's called the window object. The window object is, well, the browser's global object that we're looking at here. Everything on the window has several functions, methods, properties, all this fun kind of stuff. How tall and how wide it is, where our, cursor is and things like that. It's got a ton of properties, most of which I don't even know until I need to know about them. But nevertheless, that is the default value of this in our console log. Now, if you ever see a directive at the top of the code called useStrict, this prevents this from being assigned in a functions context, which I'll show you here in just a moment. So I'm going to comment that out for now because I'm going to come back to it. But the keyword this, like I said, it is kind of like a legacy thing because remember back in the day, JavaScript was only meant for browsers. These days, we can use it in server-side JavaScript and so many more different applications, including building native apps with React Native. It's crazy. But back in the day, it was only meant for browsers, so it kind of made sense that where all of our global variables are stored, the window object, it would make sense to make that the globally available this context, and if it's not otherwise defined. So in a function, it needs to get context, aka a value for this. So typically this will become who called it, or if we have bound or called or applied it somehow, or if no other context is given, then it's simply going to point to the window object, right? And that was the intended behavior in the original design to allow easy access to properties and methods. But like I said, that's legacy design. So it primarily exists because of these historical reasons. Again, JavaScript was meant just for the browser, and that's it back in the day. And it also makes sure that it's done this way today, so that way you still have backwards compatibility on old JavaScript code. But we know this can be very error prone. Being able to modify a global variable anywhere in your code is dangerous in a complex application. Modern web development doesn't do this. It uses a directive called useStrict that prevents this behavior instead. That way we don't have easy access to the global object and makes us write stronger, more modular code without depending on a global state to modify instead. So if you ever see this at the top of a JavaScript file you're working with, or in an article that doesn't explain it, or in compiled TypeScript code, that is exactly what's happening, right? It changes the context of this inside of functions. So let's take a look what I mean by that. What is this? Is a function that will console log the keyword this. I'm going to console log keyword this with the useStrict directive up top, and we get nothing because I forgot to call the function. Classic. Coding for 6.5 years at this point, and I forget to call the function in a demo. I'm not editing that out because we all make mistakes, right? So it logs undefined, which is what the useStrict directive does. Like I said, it is a more modern approach to code. We shouldn't have access to some global object by default assigned to this because there's no other context calling what is this. There's no object chained onto it. I haven't bound or called or applied any custom context to it. I'm not using an arrow function. It just was assigned undefined by the useStrict directive. If I get rid of that useStrict directive, look what happens now. The global object is by default assigned to the keyword this with no other context being provided. Now I keep saying that word context and objects and stuff like that, so let's see what I mean. I'm going to swap what is this from a global context, which defaults to a window object, to an object. We're going to say const obj. We'll have a name property with string value Percy, my cat Percival, who is not here for once to ruin a video. That's interesting. Age of 3, and we're going to add a property that also happens to be called what is this, and its value will also be my variable, aka the function name what is this. So if you don't know this ES6 shorthand, if the object or key or if the object's key or property is the same thing as its value, meaning what is this, colon, what is this, we can shorthand it down to the singular, just what is this, which is a really cool thing to know how to do. Now, I'm going to take the object, which is now the context, and call the what is this function on it, and let's see what happens. The context of this went from the global window to the object of name Percy, age 3, what is this function? And that's exactly what the expected output is, unless we override this with a call, apply, a bind, or if we use an arrow function, right? So it got its context from the thing furthest left of the dot, which happens to be the object. So that's what's happening here. And let's see how this differs now if we did this a little bit differently. What if I do an arrow version of it instead, where I say, what is this arrow? And we're going to have an arrow function that does the same thing. It's going to console log the keyword this inside of the object, and I'm going to call what is this arrow now down below the object so we can see what ends up happening. All right. So the arrow function bound its context when it was created, and it became the window object and not the object itself, right? This is because arrow functions have something called lexical scoping, right? They introduce a new way to handle this. Lexical scoping means that this value is captured from its surroundings, i.e. it adopts this value of the enclosing function or global context and does not have its own this dynamically reassigned. That's a big, like, kind of gotcha question for beginner interview, JavaScript interviews, where they might ask you, besides some shorthand or syntax differences, what is the big deal with arrow functions compared to function syntax? These get their value of this defined to them when they are called. This one gets it when it's when it is captured. It's captured from its surroundings, right? Via lexical scoping. So it's a little bit different than regular function syntax, and that we can also leverage this in our debouncing solution, which we're finally going to get to after this little mini lesson on the keyword this. So let's go ahead and write our first debounce function, and we're going to use some console logs to see what's going on here. I want to make a debounce handler. So let's go ahead and write our function. We're going to call it debounce, right? Debounce is going to take two things. The function we are delaying, so we're going to call that func, and a delay, aka how long do we want it to wait. Now we can just hard code a value, or we can pass in a delay, which is the better way to do it, obviously, to say I want you to wait 3/4 of a second. I want you to wait half a second before you run this function. That's the relationship we're looking at here. So what I'm going to do is the following. We're going to set a debounce timer that I will be clearing. Because again, if I just debounce a function every single time a user types, it will just kind of queue up that function to run later. I don't want it to do that. Every time I queue up a function, I want it to clear out the old one and add a new one. So I don't want to stack multiple functions in my event thread, my event loop. I actually want to be clearing out the ones that are going to be delayed. So basically, instead of stacking a whole bunch of functions to run later, I want to be stacking and clearing one function over and over again until the delay hits and then it runs it. That's what this is going to do for us. So this is going to return an inner function, and this inner function is going to do a couple of things. I'm going to, for console logging and readability purposes, go ahead and get the context of this inside this inner function and put it into a variable called context. I'm going to grab any arguments that happen to be passed to this inner function via a variable. We'll call it arguments. That will be whatever or we're going to call this one rather args, and this one arguments. This will represent any arguments I pass into this function, right? Because that's how you can grab them in this vanilla JavaScript syntax. And we can put it in a variable just called args. From there, if I currently have a queued up debounce function, I want to stop it. This is what I meant by we need to clear out our current function that's paused. Go, oh, they kept on typing, get rid of the one that's paused and add this new one. Oh, they kept on typing, get rid of the one that's paused and add this new one. They stopped typing, run the function. It shouldn't run 3 times after a delay. It should run once after a delay. So this timeout will clear the one we're about to set. So then I'm going to say debounce timer is going to be assigned to a call to set timeout. We're going to use vanilla function syntax here. And this function is going to run after this delay occurs. So then we have these parameters here. Nope, not Epic Games. Where is it? Nope, I cannot type. Okay, there we go. That was a whirlwind of stupidity happening there in my keyboard in Typo City. The point is, I did all that work just so I could draw an arrow between these two because it does help students visually see this relationship. The delay argument I'm passing in is the delay I want this set timeout to run. The arguments is a way you can capture arguments from a function. So if I happen to pass anything into, I think via this function, we get to access them. And the context of this, I'm putting it in a keyword context just so you can see what I'm about to do here. And then finally, we have to somehow call whatever our function is going to be on this delay. So I need it to return a call to my function, and I want it to apply my custom context with my custom arguments. And that right there is a debounce function. Like I said, the code itself isn't all that difficult. Understanding what the keyword this is much more difficult. But let's see if this sucker can run, and we're going to add some console logs to see what ends up happening. So I'll go ahead and make a new variable that will act as our debounce handler function. So I'll call it a debounced handler, and we're going to assign it a call to debounce. Now, debounce is going to take, again, a func and a delay. So it's some kind of function and some kind of delay. Let's do 750 milliseconds, which will be about 3/4 of a second. This inner function is going to be what runs as a result of my input. So you know what I'm going to do? I'm simply going to grab the code of my console log and put it in that curly brace and this event. Now we can see in this event, this function and debounce, they're not going to have a clue what my e.target.value is because it would have no way of grabbing the context being, well, it's not being called by the search box, which is why we have to do this apply. We're going to get the context of the search box as this, and I need it to be applied to the function, because if I have this in the outer function with no other calling context, right? There's no context calling debounce. It will be the global window. The inner function will have a context of this because it's going to be running this function as an event listener, which means it does have the this context, which will be the search box input. And if I have that, I got to make sure my inner function I'm delaying is applying that context correctly. So with that in mind, this should be all we need to go ahead and apply it on here. So instead of this anonymous function, I'm going to say use my debounced handler instead. And there we go, folks. That's all there is to it. Quick look at the code again. So remember, we have an outer function utilizing a closure on this inner function. We set up a variable in the outer function. We're going to be closing on this inner function. We're going to grab the keyword this to make sure it is the context of the input and not something else, hence why we apply it to our function we're debouncing here. We're grabbing any additional arguments passed into it, which could be an array or whatever, or a comma-separated list, depending on how you write it. We clear out that debounce timer. We assign that debounce timer every single time and wait a delay to fire the function. And that's all it is. Let's go ahead and grab our search here. And again, we earlier saw every letter being console logged. So if I speed it up and pause, it did the one search and not multiple searches. So let's do some quick console logs to finish out this little lesson here. I'm going to go ahead and console log outer function. And we're going to console log this. I want to see what this console log shows us. Now check it out. Well, the outer function, remember, it's called when I pass it and create my debounce handler. Because it has no context and we're not in useStrict, it is defined as the global window object. So that's expected. Now we're going to console log inner function this. This inner function is what's returned by a call to debounce. This is what we're passing into debounce, the delay in my func. And what's returned from debounce is this inner function that sets up the new timer every time or the new delay and the new queued up function, set timeout every single time we type. So if I hit one letter, there's the console log from inner function. And notice the context of this is the input and not the window. We need it to stay that way because if I console log what this is over here, it may be something different. And I need it to be bound not to the whatever called it, but I need it to be bound to the input, which is what this does. Function.apply context. We take the input's context and apply it to that function. And I'll call it anon-func in debounce. This is really weird to type that out, but that makes sense to me. Anonymous function inside of our debounce, right? We don't see that called until right there. So the context we bound is the input, which is why anon-func in debounce has a this context of the input, even though it's nowhere seen inside of this code. And that applies what does that for us here. And that's why I had to go through this whole process of defining what this is and why it's important, because it makes this code actually legible. Now, I guess like I said, arrow functions were a cleaner way to handle some of these crazy things. We could do the following. We could do like a spread operator on our arguments. We can grab whether they're a comma separated list or an array. It doesn't matter. What I can do from there is I don't have to call this context. I don't need to grab my arguments. I need to simply clear out my timer, and I need to set a new debounce timer. Let's switch everything over to arrow functions like this. This will be an arrow function. Get rid of that syntax right there. The outer function actually doesn't matter. It's just the inner one that does. And then I'll do a callback arrow for my set timeout, and I could just do a one-hand return if I wanted to on this sucker like that. There we go. And it's not func apply. It's simply calling func. It will get its context correctly. All we have to do is daisy chain in the arguments should they need any. And that right there is the ES6 version of what I just showed y'all utilizing arrow functions. Same thing for our debounce handler. Let's see what happens if I start removing all vanilla function syntax on these things and just switch to my arrow syntax here. And there we go. Like with the way arrows get their lexical scoping, it should correctly have the keyword this. Hey, look at that, right? The space hitch. And there you go. That is the ES6 arrow solution way of what I just showed y'all, utilizing lexical scoping and it getting its context of this from its surroundings, right? And that's what's the important part to learn of here. So yeah, there is, basically debouncing in a nutshell. It's a valuable technique in enhancing the performance of your web applications. We learned how to craft one from total scratch in just vanilla JavaScript, which I haven't done in a while, so I think it was a nice, more beginner-friendly tutorial for once, and not say, hey, spool up Vite or something like that, or Next.js for a React app so we can see a use effect in action or something. We had to learn a lot about the keyword this, the use strict directive, a little bit of history of JavaScript and why this is the global window object, how vanilla function syntax differs from arrow function syntax. For some further learning, you can look into how to use debounce to have throttling and asynchronous code, right? I think it's pretty important to know how to do throttling, which is what another version of debouncing could be. Understanding async await and promises. Whole world of asynchronous JavaScript can be really time consuming and making operations more efficient, which goes hand in hand with debouncing. The event loop is going to be really important to know because it governs the execution of functions, which is what I was talking about in this importance here. I don't want to keep adding new functions to my event loop. I want to be clearing them as I add new ones, which is why I had to do it that way. And then, yeah, I hope y'all found this interesting and very helpful in understanding what the concept of debouncing is and how to implement in vanilla JavaScript. Remember, if you have any questions or want some help with coding, you should consider joining our community membership to get videos like this, access to our courses, and so much more. So thank you all for watching, and happy coding.